For today's notes, we're going to go over sketching the graph of a polynomial function. These graphs are quite long, and this note sheet's going to take a while to get through. So today we're just going to go over the directions and then two of the basic examples, and we'll save the rest for Monday's class. So just for everyone's information, this lesson is not on the quiz tomorrow, just because we're not going to get through the whole thing. So the quiz tomorrow is just the basic parts leading up to graphing, the intro lessons and lesson 1. So here are the steps that you should follow. You don't specifically have to follow this order, although you'll notice that I always do follow the same order just to be consistent with my examples. But either way, the first thing that you should do is determine the graph's end behavior. Next, you should find the x-intercepts by setting the function equal to 0 and solving the resulting polynomial. Within this step, you want to make sure you identify the multiplicity. Next, you want to find one additional point between each x-intercept. I'm only looking for one extra point here, so if the y-intercept is in between that x-intercept value, then that's fine. You can use that point. So just one additional point between every x-intercept. And lastly, you want to find the y-intercept by setting x equal to 0 and computing the function of f of 0. This will always end up being the constant term, only if the polynomial is in standard form. All right, so right here I have two examples for you, and the next page is also some examples. We don't need to spend much time on these considering they're already graphed for you, but let's just look at the first one. So on the first one, if you were to graph this, hopefully you all recognize that you have a factor of x plus 1, which would tell you that you have a 0 at x equals -1. And right here we have the multiplicity of 2. That's this point right here. And you can see that the graph comes down, touches that point, and it bounces back in the same direction. That's because the multiplicity is 2. So it tells you what to do at that point. Next, we have a factor of x equals -1, which gives us a 0 at 1. And you can see that the graph is going to go right through that point because the multiplicity of that factor is 1. And lastly, we have a 0 at +3. At +3, same thing. This is going to go straight through the point, straight through the x-axis because the multiplicity is 1. So just to label what each part looks like, this is when the graph turns or bounces at the x-axis. And these two are examples of when the graph crosses. So there's nothing to do here. I gave you a few examples that are already completed. You can use these as reference. On the next page, same thing. Here's another example. These are non-examples just because sometimes I notice that students graph functions like this. These are not polynomial functions. Here I provided you a graph that indicates all your different multiplicities and what's happening on the graph. And two more graphed examples. So that leads us to our first example that we're going to do. Again, we're just going to do two of these today, and then the next note sheet we'll do the rest of the packet. So for this first example, we're going to start by finding the end behavior. Now, end behavior is always found when the function is in standard form. Okay, if we're looking for the function to be in standard form, that would typically indicate that we need to multiply all of this together. There is a shortcut and it's called a power function. You'll notice that I do it a lot on my note sheets. So a power function is when you take every factor and you multiply the first term together. So I'm going to highlight what I'm talking about here. We have our factor of x. We're multiplying this by the factor of 2x plus 3. And we're multiplying that by the factor of x minus 1, but with a multiplicity of 2. So I'm actually going to write that factor out twice because that's what the exponent is telling me to do. I just wrote that factor twice. To find the power function, you multiply the first term of every factor. So the power function is going to be f of x is equal to x times 2x squared is going to, x times 2x is 2x squared, times x is 2x cubed, times x again is 2x to the fourth. That's the first term of your standard form function. And then we don't care about the rest. So this here just saved us a lot of time. We didn't have to multiply these two factors together and then multiply these two and continue that until we're in standard form. All we did was find the first value. And again, that's by multiplying the first term of every factor. So from this, I can see that I have an even degree and a positive leading coefficient. Even degree positive leading coefficient indicates that as x approaches positive infinity, the function approaches positive infinity. As x approaches negative infinity, the function approaches positive infinity. I'm going to come down to my graph, and I'm just going to make a couple marks on here. I know both ends of my graph are facing up. Next, which I listed as step 2, but again, the order doesn't really matter. Next, we're going to find the x-intercepts. So x-intercepts are found by setting each factor equal to 0. Within this step, you want to identify the multiplicity of each factor, and you also want to label what happens or what the behavior is at the x-axis, and that goes along with the multiplicity. So first, we're going to have a factor of x. If we set that equal to 0, we have x equals 0, which graphed on the graph is at 0, 0. The multiplicity here is 1. So we know that at this point, the graph is going to cross the x-axis. Next, we have a factor of 2x plus 3. If we set that equal to 0, we're going to have a factor of negative 3 over 2. If we plot that as a point, it's at 3 over 2, 0. This factor happens once, so the multiplicity is 1, and that indicates that it crosses at the x-axis. And lastly, we have a factor of x minus 1, but we have a multiplicity of 2 here. That tells us we have a 0 at positive 1, plotted on the graph is at 1, 0, multiplicity 2. Because the multiplicity is an even number, it's going to turn or bounce at the associated 0. So it's going to turn or bounce on the x-axis. Okay, next I need to plot these points. So I'm specifically plotting the points that I found as x-intercepts. I'm going to plot a point at 0, 0, plot a point at 1.5, 0, just notice quickly that I just graph some dashed lines. These are sketches, so just be as accurate as possible, but you can create the increments however you want to. So you can see I just spaced my graph out quite a bit. I need to graph a point at 3/2, 0. And lastly, I need to plot a point at 1, 0. All right, after I plot these points and before I graph the behavior, so the turning or crossing at the x-axis, I need to find some additional points between each interval. So I need to find a point between these two x-intercepts, so it's either going to be somewhere up here or somewhere down here. And then I'm going to need to find a point between these two x-intercepts. So in this case, it's either going to be up here or down here. And I just need to calculate those. So you can pick any value between these. I know that this point is at 0 and this point is at 1. So I'm going to start by testing an x value of 1/2. And you substitute 1/2 back into the original equation. So when I substitute 1/2 into the original equation, I get, or I substitute in 1/2 multiplied by 2 times 1/2 plus 3 multiplied by 1/2 minus 1 squared. And when I simplify this, I have an output of 1/2. So you can just use a calculator, type it into the calculator, get your answer. But I do know that I am going to have an additional point at 1/2, comma 1/2. X value 1/2, Y value 1/2. All right, I just graphed some increments on the y-axis. Again, you can space them out however you want to, but I know I have to plot a point at 1/2, comma 1/2. Next, I'm testing a value between here. I just realized something I did. I actually graphed, I'm so sorry. I actually graphed this point incorrectly. It should be at -3/2. I did have it written up here, and I just graphed it wrong, so make sure you fix that. All right, so I just replotted that point at -3/2, and now I'm looking for a point between those two x-intercepts. So I'm going to test when x equals -1. That's right here. If x equals -1, I substitute this into my original equation, and I have -1 multiplied by 2 times -1 plus 3 multiplied by -1 minus 1 squared. When I type this into my calculator, I have an output of -4. This is going to be an ordered pair at -1, -4. So I'm plotting a new point at -1, -4. The last step is to find the y-intercept, which is found when you substitute 0 in for x. You can probably already tell what the y-intercept is because we do have it graphed, but when you substitute 0 in for x into the original equation, your output is 0, so your y-intercept is at 0, 0. And now it's time for the graph. So we need to pay attention to our zeros and our multiplicities, as well as making sure we touch all points. Remember that this is a sketch, so it does not have to be perfect. You just have to hit all points. It might look a little bit different than mine. Your curves might be slightly different. That's totally fine. I like to start on the left side of the graph, make sure my end behaviors are matching what I'm graphing. I know I need to start facing up towards positive infinity. I'm coming down, I'm approaching the 0 at -3/2, and my multiplicity tells me that I'm crossing through this point. Somehow come down, touch your extra point, whether you just make a curve right at that point or you go through it like I did. You come up, we're approaching 0 where the multiplicity is 1, so we cross through, touch your extra point, come down to 1 where it bounces and we head back in the same direction. And once again, make sure your end behavior is correct. All right, now let's take a look at number 2. This is the last one we'll do for today. Number 2 is in standard form, so to start off with finding the end behavior, we are going to have to identify the power function. And that's what we did before, where I had you write out the expression, write out every single factor. So if you have a multiplicity of 2, make sure you write that factor out twice. So x squared is the same as x times x minus 2 times x minus 4 times x minus 5. The power function is when you multiply the first term in every factor. In this case, our power function ends up being x to the 5th. And we don't care about anything else. Because this is an odd degree and a positive leading coefficient, that tells us that as x approaches positive infinity, the function is approaching positive infinity. And as x approaches negative infinity, the function is approaching negative infinity. So on the left side of my graph, it is facing down, and on the right side, it is facing up. Next, I have my x-intercepts. My first x-intercept is x squared. Set that equal to 0. We have x equals 0. This happens twice. That tells us that the graph is going to turn at that point. We have a 0 at x equals positive 2. This only happens once, or the exponent is only 1, multiplicity 1, the graph crosses. X equals positive 4, also exponent of 1, which means multiplicity of 1, the graph crosses. X equals 5, 5 comma 0, multiplicity 1, crosses. I'm going to sketch out my x values. I need to make it all the way to 5, so make sure you can fit up to the increment of 5 on your coordinate plane. Plot these points at 0, 0, 2, 0, 4, 0, 5, 0. We need to find a point between each value, so I need to find a point between these two, and between these two. Remember that when you find additional points, you pick an x value, you substitute that back into the original equation, you solve for y. So I'm actually just going to tell you the ones I picked to save a little time in this video. I'm going to start right here at x equals 1. When I substitute x equals 1 into the original equation, my output is going to be negative 12. So I'm going to have an ordered pair at positive 1, negative 12. The next ordered pair that I found was when I tested x equals 3. That's between my next two intercepts. When I substitute that into the original equation, use my calculator, the output is 18, so I have an ordered pair at 318. And lastly, I tested when x is equal to 4.5. Here the output is negative 12.66. So I have a point at 4.5, approximately negative 12.66. All right, I need to make sure I can graph all of these, so make your increments on your y-axis reasonable to make sure you can graph negative 12 or down to negative 12 and at least up to 18. So I'm actually going to go up by increments of, let's go up by increments of 2 instead of 1. I need to plot a point at 1, negative 12, another point at 3, 18, and the last point at 4.5, negative 12.66. Before I sketch my curve, I just want to indicate if you do something like this, please just mark it on your graph. So typically we go up by increments of 1, but if you're going to change that to increments like of 2 or something else like I did here, just make sure you indicate it so I can see on your answer key. All right, the last step is to find the y-intercept. And the y-intercept is when you substitute x equals 0 into the original equation. When you do this for this example, your output is also 0, so your y-intercept is at 0, 0. And now we need to graph. So I'm going to start on the left side knowing that I'm facing down. I'm approaching the 0 at 0. And at this 0, the multiplicity is 2, so it hits that point and it turns back in the same direction. We come down, we touch our extra point, we're heading back towards the next 0, which the multiplicity is 1, so it crosses, touches the next point, crosses through the 0 at 4, crosses back through the 0 at 5. I missed that, but that's okay, it's just a sketch. And that's my final graph. Again, these are just sketches, so they do not have to be perfect. Mine are not perfect. Make sure you just hit all points. That's the most important thing. And label everything. Okay, that's it for today. You have one Go formative graph to do, and that's it. So we will finish this note sheet next class, and your quiz tomorrow does not include any of these.